Hi, good morning to you all once again. We still discussing plane geometry 2, theorems and circles. And um thus far we've been able to discuss property 1 and 2 with some illustrative examples. For today's lesson, we'll be continuing with the rest of the properties. How many properties do you think we are left with now? Since we've done with 1 and 2. Yes. Yeah, 6. Okay. So let's look at the rest of the property. What is there? Let's see. So property 3. Now remember, now you know two properties. I can give you a question and you would need to apply 3 or 4 properties at a go, different ones. You need to employ ideas from 3 or sometimes 2 properties in order to arrive at a solution. So just watch out. So property 3, the angles a chord the angles are chord just right. My machine again. Subtends at the circumference. On opposite segment. Sum up to 180 degrees. Did it rain or something?
No.
Okay, okay, okay. You can write supplementary, but when we are solving and you are indicating the property, don't include it. I just want you to know when angles sum up to 180 degrees, we say they are supplementary. Okay, yeah. So the angles are called subtend at the circumference. Yeah. In the sorry, on opposite segment are supplementary. There is an error in the spelling. It should be Tary. Yeah, yeah. Tary. Okay, so let's explain with a diagram. Let me know when you are there. Okay. So what I mean is that when you have this, yeah, then you have a chord. Now, and the chord produces an angle right here. Let's do that again. Yeah. So it makes an angle right here. That's all, man. And that same chord makes an angle right here. Let's go again. You see, so that chord makes an angle on the circumference. It also makes an angle on the circumference in the opposite segment as indicated. Then those that two angles add up to be 180 degrees. Then you can say A plus B is equal to what? 180 degrees. It's a property, but it can help you going forward. Sometimes you might be given some unknown angles and you'll be asked to search for it. Okay. Now you know that when one chord makes angles on a circumference at opposite segments, okay, then those angles add up to be 180. If this property do come to your mind, then you know that if you know one angle, let's say A was 20 degrees, then you can say, but you and I must add up to be 180. So if I'm 20, then the other one will be what? Yes. Am I not asking you a question? Let's continue. So let's look at this very one. So over here, A must be a number. Then you notice that there is a number in the diagram. There is just a number in the diagram. So we have to see if it has any effect on the A. So that will mean extending this to its feet. You will notice that this chord produced the 130. Now you ask yourself, how is this chord having an effect on the A? Oh, no. Is this chord having an effect on the A? Yes, it does. So this chord produced the 130 degrees. That same chord produced the A. Now, it produces these angles where on a circumference at opposite sides. Once you notice that the angles are produced on the circumference at opposite sides, then that property you just studied come into place, property 3. So when one chord makes angles on the circumference at opposite sides, they add up to be 180 degrees. So A plus 130 degrees is equal to 180 degrees. Then you write a property. On opposite segment, sum up to, or you can simply say on opposite segments are supplementary. So A will be equal to 180 degrees minus 130 degrees. A is what? Yeah. So try this. Now, I'm amending the question. O is a center. So if you see O anywhere is a center. All right, I'm giving you 6 minutes. Work on this quickly. When it's 30, we'll be done.
In everything, the whole
All right, we are looking at the solution that was presented. So let's take a look at the first one. So we have 140 degrees and okay. So that's what we have. I understand your light is off.
So I selected the bonus.
All right. M is equal to, let's see what they have there. M is equal to what? A over 2. Where is A? I'm talking to you, so you have to respond because you made these solutions. Where is A?
So I use A to represent the 140.
Where is A in the question?
I use A to represent one. Otherwise, A in question.
Where is A in the question?
There's no A in the question.
So the A you indicated there, would you be at the examiner's office to explain yourself? When you are done with your WASI and they are bagging the questions to wherever it will be marked, would you follow the vehicle to go and explain yourself? So where from the A and then what else again?
You should see. No, sorry.
A over 2. Where from that? If you are saying the angle a chord produces at the center is twice the angle, it is twice its subtends at the, I don't know what it even means. Subtends at the circumference. How is twice of something equal to something divided by something? What solution is this? Do it again. And the other one, make sure you've written something sensible before you take a shot again. Over 9 students in a classroom, there's a solution you're producing for me to actually assess. Huh? Is this what I taught you? Is this what I taught you? Or you are using phones, AI, and writing rubbish? Is this what I taught you? 70 plus n equals 1, no degrees, nothing. Yeah, just do you realize this is nonsense? You know what you have to do. You have to press your neck before you do the right thing.
And me question.
All right, so if we take a look at this question. So who are those chatting on the background? Yeah, between 140 and let's see, because it's one chord producing the 140 and that same chord is producing the M at one place. So I think if I look at this, I can see the angle a chord subtends at the center, which is 140, is equal to 2M. Yeah, 140 equals 2M. They did it the other way around. Make sure you don't go and confuse yourself at the examination hall. Because as per my observation, you're not good enough to be making things complicated for yourself. The property reads the angle a chord subtends at the center. What angle is there? What angle is it not 140 degrees? 140 degrees is means equal to equals the angle equals twice the angle it makes at the circumference. So 140 degrees equals twice 2m. But you do it the other way around. I don't know who you are trying to impress. You try to make everything complicated. Meanwhile, you are not actually good. You are not actually to your perfection in mathematics. I just don't understand. In your earlier example, you started by dividing the thing over two as if you are A1 student. Meanwhile, you are still under training. When I teach you the pathway, instead of you to stick to that, you'll be doing your own thing, trying to be complicated. Now you have m equals 70 degrees. Now n plus m equals 180. Instead of you to state the property up, you decided to bring it on the next step. Why is n plus m equals 180? Why is n plus m equals 180? I'm asking you a question. I'm asking you a question.
It is the formula.
What formula?
Because the angle equals at the opposite segment map to 180.
At the circumference on opposite side. So the property must be written by the side of that equation. N plus m equals 180. Because it's based on the property you made this establishment. So you can write the property anywhere. Now m is already gotten. So n plus 70 degrees equals 180. N plus 70 equals 180. Yeah, this repetition again. N equals 180 minus 70. N equals 110. Take note of all the corrections I have made.
Yes, sir.
I'm waiting for the next one. Yeah, so they also could solve the question 4. Question 4, like I said earlier, looks straightforward. So let's see. Okay, let's see. So question 4, well, this is going to be 65 plus b equals 180 degrees. Yeah. So 60 b plus 65 equals 180 degrees. The angles are cos are tens at the circumference on opposite segments sum up to 180 degrees. Yeah, so you just make b the subject. That'll be 180 minus 65, 115 degrees. So that's correct. Now, what's the problem with the number 3? What's your response? Yeah. Yeah, what did you get?
So you got 50. 50
Come
degrees.
again.
50 degrees.
Explain.
The degrees property 2,
Which is
which is um, the angle equals subtends at the center implies the angle is subtends at the circumference.
were you in that class when I was teaching that property? I'm asking you a question, yes or no?
Yes, sir.
Did I assign NB? Note carefully to that property.
Yes, sir.
Read that for me.
The angle must be, both angles must be subtended the same segment.
So the two angles, are they subtended in the same segment? So are you correct or you are wrong?
Wrong.
Yeah, you are wrong.
Yeah, 8 got to 80.
A is equal to what?
80.
A is equal to what? I barely hear you.
180. Question 3, 130.
So the others, what are they doing? They are just spectating. Or what exactly? And how did you get 100? It cannot be solved. You are just forcing something to be there when the thing cannot. So if the thing cannot be solved, you can't say it. Yeah, it's undefined.
Then so number 3 is wrong.
Number 3 is what's wrong. A is in math when something cannot be solved, what do you write?
Undefined.
A is undefined. I want you to use your brain. The properties you are having, 100 degrees is made at the center. A is made at the circumference. So you may think your property, I don't know what property it is, but I said when a chord produces angle at the center and that same chord produces an angle at the circumference, the one at the center is 2 times the one at the circumference. But I added that the two angles must be made at one place because of questions like this. They must be made at one place. It is made at opposite place. So that property doesn't work here. A is undefined. It cannot be solved. So watch out and shine your eyes going forward. You go and open your textbooks, Akiola, you might meet a question like this. But they had an answer, my dear. Go and watch that question again. You notice that they will probably inscribe that, that structure is a rhombus, or there will be markings on the diagram. They'll mark the diagram. Like you draw a diagram like this, and then there will be markings of like something like that. If it's a rhombus, things changes. Rhombus exhibits some properties. We'll talk about that in the latter part when I'm done with the theorem. Rhombus exhibits some properties, so it affects the solution. But there is no indication that it's a rhombus, or I told you. Yeah. So A cannot be solved. Period. Now, the way you were just guessing answers anyhow. It's like it's either you don't understand the property or you are making your own theorems now. Patience, Aristotle. And then who else again was guessing wrong answers? We'll give them a Ryan or Pascal. Anyway, don't mind me. Let's continue. Let me add one more property. You can't just come to school and learn just property, just a single property. What property are we on?
Property 4.
Yeah, so property 4. But I mean, they did well. That's a good try. Others will just sit there and be quiet as if they are dumb. They will not contribute anything, and you'll be copying. We write for you to copy.
Yes.
You should be very careful. Anyway, the angle, those that contribute, they are the ones that get to the understanding all the time. Ask them. Yeah, if you get an answer wrong, do we beat you or scold you? No, we'll scold you, but we don't beat you. And I think the most painful thing is when you are beaten, right?
No.
Which one? When you are scolded.
Yes.
That's the one. Is your face in a recording? Your face is not in a recording. The angle and diameter subtends at the circumference. Okay. Then now when you make a mistake, I will applaud you.
Okay.
The angle and diameter subtends at the circumference. The angle and diameter subtends at the circumference is 90 degrees. You can write complementary. Like when you are solving, don't include it. But instead of someone saying it's add up to be 90 degrees, you can just say complementary.
They are waiting for you.
Yeah, oh, you waiting for me.
Yes.
Yeah. So um let's have a circle. Yeah. Oh, now you see they're talking about diameter, meaning there must be a center in our diagram. So guys, the circle I'll be drawing O is a center, okay. Yeah, so um O is a center. Now let's see something. So and we all know diameter, right?
Yes.
Yeah, any line, straight, any chord that runs through the center. Now, when a diameter produces an angle at the circumference, it's 90. Okay, so this is a 92. In math, we like using this kind of arc. When a diameter makes an angle at the circumference, it's 90. Yeah, it's 90. You can be asking, so what's the usefulness of this? So going forward, um, do you recall that we have a triangle called a right angle triangle, right? They have one side to be 90 already. Okay. And it is learned that the other two angles must add up to be 90 as well, right? So I can give you here to be 70 and you should be able to know E, isn't it? It's a right angle triangle. Victoria, if here is 70, what is E? Do you remember your right angle triangles?
Yes.
So if here is 70, what is E?
20.
20 US dollars or Ghana
Ghana.
20 degrees. Do you understand it that way?
Yes.
There is something I have to teach you, but I'm not there, so I don't want to complicate things. So let's appreciate it like this. So the diameter, when you discover it's a diameter, it's a right angle triangle. The angle it makes at the circumference is 90. So I appreciate it as a right angle triangle. What it means is that the other angles must be what? Must add up to be 90. So when I give you one, here to be 50 degrees, and I ask you to find Z, this is what you're going to do. Just write Z to be equal to 90, right, minus 50, isn't it? Then you write the property in brackets that the angle, the diameter subtends
Okay, so
at the circumference.
it's 90 degrees.
It's 90 degrees. Then now Z is I think 40 or so. Yeah. Any question?
No, sir.
So all the time go like this. Your time is 10:30. I can't 1 minute to 30. So use the 1 minute to write. I can't go for that.
Thank you.
This is the
Thank
moment
you.
you've been waiting for. Yeah.
Thank you very much. That's nice.
Jackie, you've not been in school for a while.
Yes.
Are you happy about it?
No, sir. Sir, please, I moved to Ablekuman, so when I wake up in the morning, it's time to. The place is fine.
I'm coming. Hold on. You hold on. All right. So this is the end of this session. In our next series, we'll try more examples and look at the rest of the properties. Thank you.
Thank you. Bye.